Hey guys, today we're going to be talking about our third different type of transformations, and today we're going to be talking about rotations. Okay? You're very aware of what a rotation is, but you do need to know some formulas on how to rotate a shape certain ways around the origin. So let's go ahead and look at these four and decide if they are a rotation. Okay, so this first one, well, it looks like you kind of reflect it over this reflection line here. So this is not a rotation, this would be a reflection. Hey, what about the second one here? On this one, you're actually rotating on this point right here, and it rotates all the way around, and then they would end up lying on top of each other. So this indeed is a reflection. Hey, this guy is going to be a translation because you can slide this blue shape over and he lands right on top of the red shape. So no, this is not a rotation, this is a translation. Okay, on this one, you have a common point right here, and you could rotate this blue shape or this red shape all the way around to land on the blue shape. So this would be a rotation. Okay, so let's get down a proper definition for a rotation. And a rotation is a transformation about a fixed point. A transformation about a fixed point. All right, there's going to be three different definitions that you need to know today on how to rotate a shape around the origin at a certain degree. Okay, so the first one you need to know is 180 degrees about the origin. Okay, so originally it's going to give you a ordered pair in your XY form. Well, to get it to be rotated 180 degrees around the origin, it's always going to be going to minus x minus y. Okay, so we will have to convert those for 180 degrees around the origin. Okay, the second type I need you to know is 90 degrees counterclockwise. Okay, so 90 degrees counterclockwise is of course going to give you an xy coordinate. And then you're going to have to convert it to minus y x. Okay, so that's going to be your counterclockwise. Okay, the third type that you need to know is 90 degrees clockwise or around the origin. Okay, 90 degrees clockwise or around the origin. And this one's going to go from xy to y minus x. Okay, so these are the three that you need to know. Commit them to memory. You will need to know them for a future test. Okay, so this first one, it says we want to rotate triangle JKL with vertices 2, 2, 4, negative 5, and negative 1, 6 by 180 degrees around the origin. So let's go ahead and graph those. Okay, so our first one is 2, 2. So let's graph that point. Then we have 4, negative 5. Okay, so this point right here. And last one is negative 1, 6. 1, 2, 3, 4, 5, 6. Okay, so let's connect our triangle here. Okay, so there's our triangle, kind of a poor shaped triangle, but you get the picture. And we need to go ahead and rotate this thing 180 degrees around the origin. Okay, so we have our original ordered pairs, which are 2, 2, 4, -5, and -1, 6. And we need to convert these by 180 degrees around the origin, so we need to go from xy to -x, y. So basically we're just changing the x coordinate to its opposite. Okay, so from 2, 2 we would become -2, 2. From 4, -5 we would become -4, -5. And lastly, -1, 6 becomes 1, 6. Okay, so let's go ahead and graph our new points in red. So we have -2, 2. We have -4, -5. 3, 4, 1, 2, 3, 4, 5. And lastly, we have 1, 6. So over 1, up 1, 2, 3, 4, 5, 6. Okay, so there's our new triangle that is rotated 180 degrees around the origin. Okay. So there's a few things that you need to know about rotations. Let's try a few more on the back. All right. Okay, so this number 3 says rotate triangle RST with vertices 0, 0, 3, 1, and 2, 4 by 90 degrees counterclockwise around the origin. So let's go ahead and graph our points first. We know that we have 0, 0. We have 3, 1. And we have 2, 4. Okay, so here is our triangle. And we want to rotate that thing 90 degrees counterclockwise. Well, what's the formula for counterclockwise? We know the formula is going to be from x to y. And then to rotate it 90 degrees counterclockwise, we want to go to -y, x. Okay, so let's start with all of our originals. We had 0, 0, 3, 1, and 2, 4. Okay, so the first thing we need to do is flip-flop our coordinates and then change the sign of y. Okay, so from 0 to 0, if we flip-flop it at 0, 0, and you can't change the sign of 0, so it just stays how it is. The second one, flip-flop our coordinates, change the sign of y. And we'll do the same thing for the last one. Okay, so let's go ahead and graph our new coordinates in black here. So we have 0, 0. We have -1, 3. And we have -4, 2. Okay, so if we draw on our new triangle, that would depict a rotation of 90 degrees of our original red triangle. All right, let's try a few more here. All right, if we want to rotate 90 degrees clockwise around the origin, that would give us the formula xy goes to y -x. Okay, so if we take our original points and we plot them, we'd have 1, -1, 4, -2, and 3, -4. Okay, so here's our original triangle, and we want to go ahead and convert those 90 degrees clockwise. So let's go ahead and take the points 1, -1, 4, -2, and 3, -4, and convert those. So we're going to flip-flop our coordinates and change the sign of our x. Okay, so we flip-flop them, change the sign of our x. flip-flop them, change the sign of our x, and flip-flop them, and change the sign of our x. Okay, so now we can go ahead and graph those guys. So we have -1, -1. We have -2, -4. And -4, -3. Okay, so we can go ahead and draw our points. Okay, so that would be a 90 degrees clockwise rotation of that triangle. Okay, last one, we're going to rotate this thing 180 degrees around the origin. All right, on the last one, we're rotating this triangle with vertices 0, 3, 3, 5, and 4, 0, and we want to go 180 degrees about the origin. Okay, so let's go ahead and graph our 3 ordered pairs here. We have 0, 3. We have 3, 5. And we have 4, 0. Okay, so here's our triangle. And we want to rotate that thing 180 degrees. Remember, 180 degrees, you're going to go from xy to minus x minus y. Okay, so from minus x to minus y. So let's go ahead and look at our vertices. We have 0, 3, we have 3, 5, and we have 4, 0. So all we're going to do is change our signs for each one of them. So 0, 3 becomes 0, -3. 3, 5 becomes -3, -5. And 4, 0 becomes -4, 0. Okay, so let's graph these, and let's do it in black. Okay, so we have these 3 ordered pairs. We have 0, -3. We have -3, -5. And we have -4, 0. Okay, so if we graph those points and draw our line, there is our new triangle that has been rotated 180 degrees around the origin. All right, see ya.